I'm Harpreet Kaur and I welcome you all to a live and interactive session. This is our online training program on integration of virtual labs in teaching learning phase 3. This is the umbrella theme of our training program and you are watching this training session of ours on PM eVidya channels from 6 to 12 and also on our YouTube channel NCERT Official. Well, this session, as I said, is live and interactive, which means you can participate in the session with your questions, queries, suggestions and feedback. Yes, so today is day 3 of the session. Yesterday on day 2, we talked about virtual lab as a teaching learning tool for biology. And today on day 3, we will be talking about virtual lab as a teaching learning tool for physics. So if you have any questions regarding this, please feel free to get in touch with us. You can give us a call on 8800440559. That's a contact number for you. And if you wish to write an email to us, we have a dedicated email ID. And that is diksha.training@ciet.nic.in. Last but not the least, we are streaming live on our YouTube channel NCERT Official. So you can always go to the comment section, put in your questions there, your suggestions, and get in touch with us instantly. Well, as you all know that this training program covers phase 3. It means we are specifically catering to the northeastern part of the country, which includes states like Assam, Arunachal Pradesh, Manipur, Meghalaya, Mizoram, Nagaland, Sikkim and Tripura. But as such, these training sessions are open to all. Anybody can watch them, anybody can participate and anybody can take the benefit of the same. Now, why we're having these training sessions at the first place? Well, if I share a little overview with you, then I have to say that these online training on integration of virtual labs in teaching learning phase 3, it covers NEP, that is National Education Policy 2020 recommendations and guidelines for digital education, particularly for virtual labs. And also it covers its significance and scope. Further relevance of virtual labs for teaching learning of different subjects across the curriculum will be explained in the sessions to come. And now once again, let me tell you that this is a training program under the umbrella theme of integration of virtual labs in teaching learning phase 3. Today is day 3 and we are going to talk about virtual lab as a teaching learning tool for physics. Now for this discussion, let me introduce you all to our experts who have joined us today. We are joined by Dr. Priyanka Verma, Ma'am is Senior Academic Consultant from CIET NCERT, New Delhi. Ma'am, namaskar and welcome to the session.
Namaskar, ma'am.
We are also joined by Dr. Uma D. Sharma, Ma'am is Academic Consultant from CIET NCERT, New Delhi. Ma'am, namaskar and welcome to the session. And now with these two, I'm going to take this session forward with my questions, of course. And the very first question that I have is, of course, for Priyanka ma'am. You know, ma'am, we all know that experiments, they play a very crucial role when it comes to sciences, be it any branch. Because today we are talking about physics, so I will talk in the context of physics itself. Yeah. So physics, they play a very important role. But don't you think that theory is enough to make the concepts understandable to students?
Okay. Of course, in the subject like physics, theory is always not enough to understand the subject.
Okay.
So let me first explain you what is the basic concept of physics is. So physics is basically the science that deals with it explores the behavior of the matter, energy and the forces that govern them. So it helps us understand the universe from subatomic particles to the cosmic properties of cosmic phenomena in the environment. So it drives technological advancements that improve our daily lives, such as the computers and the medical devices also, renewable energy resources, etc. All these kinds of things. So physics, it fosters the critical thinking and problem solving skills that are valuable in any field. So let me show you a slide also where I have concluded these points. So physics, it basically deals with the universal laws, behaviors, relationships for the physical concepts. It relies on the experiments, questioning, interpretation and their logical analysis. It's all about understanding by observing the physical events around us. So it is all about what physics is. Now, there is a lot of significance of the experiment in the subject like physics. So a theory is basically it cannot propose a new phenomena, but without experiments confirming it, a theory of any phenomena, it remains speculative. So, for example, the famous example of the Higgs boson, it was predicted in 1964, but it was experimentally confirmed only in 2012 at the CERN. So it is a very good example that theory cannot be validated without experimentation.
True.
So as you can see on the slide, physics relies on experimentation to validate the scientific concepts, theories, and also there is a very important point of the hypothesis testing. So concepts in the physics, they are difficult to grasp without hands-on experience. So experiment allow us to visualize the concepts in a better way. So there is also uncertainty in the physics. Uncertainty is inherent, and experiments allow the physicists to quantify these uncertainties. So theories often make predictions with some degree of uncertainty, and experimental results help to refine the precision of those predictions. Also, as far as the case of data interpretation it is concerned, so physics develops the essential scientific skills of data collection, analysis, critical thinking. It also develops the problem solving techniques of the learners when we do experimentation in physics. Also, if there is a student, he is not finding studying physics enjoyable, then what is the point of studying that subject when you do not enjoy that subject? So, to make this subject more engaging, experimentation is very necessary, because when students, they do hands-on experimentation of any concept, it ignites their curiosity, foster the innovation, and inspire the learners for the further inquiry that leads to the technological advancements. And also, for conducting any experiments, let me explain you what is the concept of scientific methods or the science process skills. So basically in physics or in science, you can say that we require some specific kinds of skills to do the experiments. These are like, you have to record the observation, you have to interpret the data, all these kinds of skills you require, and these are known as science process skills to do some experiments. So now to apply these skills, you will of course do some experiment, and in science, when a new discovery is there, all the pattern that is followed comes under some scientific method. So basically, scientific method, you can say it's a step-by-step process that is used to conduct the scientific investigations by the scientists. So these are the steps that you can see on your screen. For example, at first point, it's written observation of the physical phenomena. So scientific methods to discover any process or to discover any phenomena, it starts with the noticing of some interesting features or phenomena around you. Suppose you have seen some event, you have observed some phenomena, you will note down that event, you will note the recordings or readings, what that phenomena is. Obviously, the next question that will come to user's mind or the learner's mind will be how this phenomena is occurring. What is the reason behind this phenomena? So this is the question that will be under analysis part, that you will have to analyze the question. Then after that, question comes in your mind, then you will obviously you will start to answer that question, that maybe this is the reason for this phenomena, this may be the reason for this phenomena. For that, you need to make hypothesis. So hypothesis basically it's a prediction about the possible answer to your question, or you can say it's an educated guess kind of a thing. Okay, so next part is after hypothesis, it's the prediction part, that you have to predict the outcome of your experiment or observation if your hypothesis is correct or not. Now, you have made some prediction, then you will now want to test that prediction is correct or not. So, next part is the main part, which is experimentation, as you can see, or testing your hypothesis. Then you do some experiments and you test your hypothesis. So, suppose you carry out the experiments and the result of your hypothesis, your experiment which is not supported by your hypothesis, you have done experiment and result comes, but if it does not support your hypothesis, then what you will do? You will consider another hypothesis or you will reinvent your hypothesis. But if your answer is supported by the experimentation, then you can develop that theory into a concept, that phenomena into a theory. So theory is basically a well substantiated explanation which is based on repeated testing and evidences. So to build a concept, you need to recheck again and again your hypothesis by doing the experimentation. So you have many examples that will make a concept, and after many concepts it makes you a principle. So this is basically the scientific methods.
Well, you're absolutely right, because theory indeed is not enough, because we know anything, any fact that is there in science is backed by a logical reasoning, and for that we need to conduct experiments. We need to prove it through experiments that this is happening, this is the process, and theory of course then explains it sometimes in simplified terms as well, so that everybody can understand. Now we all know that theory and experimentation, they go hand in hand when it comes to sciences or any branch of science, let's say physics for today. But again, you know, making students understand these complex concepts of science is not that easy. I have studied science in secondary classes, and think about those who are studying in senior secondary classes and probably in higher education as well. I remember as a child I never got my fair chance to perform experiments in laboratories because of many reasons. Sometimes the period was of shorter duration, equipments were not there, and teacher wasn't able to provide enough attention to each and every student. Now, Priyanka ma'am, I'm sure there are a lot of problems that a teacher faces while teaching physics, you know, in a classroom. So let me ask you about those problems that are faced by teachers while she or he is trying to explain certain concepts of physics, and also, is there any solution for those problems?
Okay, so according as many of the teachers, in fact all teachers, they know cone of learning.
Yeah.
So according to the cone of learning, students, they often retain very less information from the passive activities like reading textbooks or listening to the lectures. It is only maximum to a 20% of the content they can retain through this process. This means that traditional methods, they may result in the low retention. But with the delivery of the same content in the video mode, what happens? It increases the retention to almost 50 to 60%. But to improve this learning process further, you need to make some hands-on activities, direct experiments, which increases this retention rates to 70 to 90%. But this is the main problem that teachers face, that hands-on activities which have the highest retention rate are not always easily available or feasible due to the limited resources, time or space. So despite our best efforts, we often find that children struggle to grasp the abstract concepts like the spherical shape of the earth, and how landforms they are formed, created, formation of the mountains that takes centuries to make them, plateaus take centuries to make. So this long process, these kind of concepts, they are very difficult to grasp by the students. So we may feel frustrated, in fact, when children don't understand the concept, such complex processes. So what's the solution for all this thing? Obviously, you will have to unlock the higher retention with the creativity solutions, even when hands-on is not an option. So, but how it will be done? So, it can be done by the use of technology. So, here comes the solution, virtual labs. As you can see on the screen about the virtual labs, what these are. So they offers a new way of exploring the abstract physics concepts without the need of any traditional physical laboratory. These are the virtual platforms that blend the interactivity of the learner by immersive content. So as you can see, virtual labs are basically computer-based activity. So their goal is not to replace the teachers, but to explore how immersive technology can be integrated into the teaching learning process, enhancing the content in the ways that make it more accessible, engaging. So with the advent of the newer technologies, we must reinvent our role as the educators to ensure that children have access to these tools. It's crucial that we do not deprive them of the modern technological advancements, as failing to keep this would make us outdated in the eyes of the children. So this impact of technology is far-reaching, benefiting the students worldwide. So as you can see on the screen, virtual lab, it's a computer-based activity. It's basically an interface that replicates the real-world setup around us to explore the scientific concepts. It's generated through the computers completely. For example, you must have seen the gaming apps. It is similar to that kind of atmosphere, but here 2D, 3D models, they are present in the interface with which a learner can interact. Here, interaction with the experimental apparatus or the other activity is done via a computer interface. And these virtual labs, they are resource-rich learning environment, means they have all kinds of tools like dragging, you can drag the objects, and interface here means whatever you see on your computer screen. So it's resource-rich learning. It means that you have all kind of resources like PDF files of the experiments. There are simulations, there are videos, everything connected to that experiment is available in that interface. And most importantly, it is based on the concept of the remote experimentation. It is just a click away from you. You can operate it remotely even from your home.
Absolutely. You're right that virtual labs are opening up a lot more avenues for learning. You talked about immersive technologies. We all know that they provide such an engaging experience that whatever concepts you have learned, they stay intact in your memory for a longer period of time because you've enjoyed them while performing them. But where are these virtual labs? Where do they exist and how can we access them?
Okay. So, virtual lab, you can access them via Diksha portal of CIET NCERT. So, this Diksha portal, it was launched in 2022 that helps the learners and educators for the experiential learning. So, you can go to the website or the link that is shown to your screen. Let me show you the website.
Yeah.
This is the Diksha website and this is the virtual lab verticals of the Diksha portal. As you can see, it's written all about virtual labs here, and it is the virtual lab e-content. So it is from grade 6 to 12. Okay. When you can click on any grade, for example, I have clicked on this, the explore button. So two mediums here are shown to you, English and Hindi medium.
Okay.
You can click on any medium, for example, English, then it will show you further the subjects, mathematics or science. You can click on any subject and the screen will open.
And I'm sure that very soon these will be available in the mother tongue, different languages of India as well.
Yeah, it must be available.
Well, it's a work in progress.
Yeah. So, it's taking some time.
Yes.
So, it will show you a screen where all experiments will be listed for any grade.
And there are many experiments that have already been saved in the system, so you can explore them. And of course, before going to a laboratory, you can actually prepare yourself, you know.
Yeah.
So it's a good homework that you can perform. And would you like to retry?
Yeah, it's getting open.
Okay. And I think all you need is stable internet connection to access these virtual labs. You talked about a remote experimentation. No matter where you are, where you're sitting, you can always perform an experiment at your own pace.
Okay. So I have clicked on class 12. So this kind of screen it will come. Now here you can see that these are the experiment number 1, 2, 3, etc. You can click on any experiment. Then here are the resources: experiment PDF file, explanation resources. For all experiment, all these stuffs is available here. So you can go to an experiment, any experiment, and you can have a look for that. So this will be the link for like this for any experiment. You can click on the link and experiment will get open.
Okay.
And using that simulator here, you can do that experiment.
True.
Theory. For theory, theory of the experiment is available here. Procedure is also mentioned, animation, video, simulator, self-evaluation. For example, for any physics experiment, this kind of theory, is available, procedure is available, simulation.
So theory
all
related
these
to the
things.
experiment that you are going to perform.
Yeah, it's
Okay.
available.
Nice.
So this is how you can go to diksha.
Virtual labs.
Yeah.
And I'm sure it has a lot more benefits when compared to physical laboratories.
Yeah, it has benefits also.
Okay.
So
would you like to elaborate on the same?
yeah. Okay. First of all, it's free to access. You do not need to spend any money. These simulations, they are interactive and it's a complete lab learning environment. There is a learner's autonomy. Everything is on the learner. He can learn the experiment at his own pace. It's available anytime, anywhere. It bridges the constraints demographically. Inclusivity and equity, as it is mentioned
Yes.
in the NEP, they are followed here. It is cost effectiveness also. So
Right.
these are some general benefits for any subject. These kind of benefits are there.
Okay.
Now I'll talk in terms of physics.
All right.
So for complex phenomena like electromagnetic induction, optics में refraction and diffraction, these are very easily explained using this virtual labs. And visualization of the invisible concept, for example, atomic structure, you cannot see with the naked eye. Sound waves, gravitational fields, you cannot see with your naked eye. So all these visualization is very easy to see in the virtual labs. And here environment is controlled, unmatched precision and accuracy. For example, in free fall experiment or projectile motion, all accuracy that you need to measure is available here.
Right.
Okay. Also, when experiments are very long, for example, in thermal physics, pendulum experiment, you have to note down many readings. Magnetic field mapping, these are long experiments, but here you can do it in seconds, very quickly. And result is also automated very quickly. Real-time data process for the immediate results is also there. Scalability issue, large group of students, they can be addressed simultaneously. It is also resolved here. And it is many times said that it offers the pre-lab and the post-lab sessions both. So the personalized learning means progress at your own pace is also here. For example, some students are not easily, they cannot understand the electrical circuits.
Yeah.
So here they can repeat the experiment again and again, practice the experiment. So this is the main benefit for them. And also it is safe exploration and risk-free experiment. For example, in some experiments we need high voltage or a high energy. Some experiments also composed of the radioactive elements. So for that kind of experiment, if we use virtual lab to make the concept understandable to others, it's very easy and safe here.
Absolutely. Well, after learning about the benefits, I can safely say that virtual labs are not just providing hands-on experience, but they're also, I would say, complementing the real physical laboratories that exist and that we commonly know of. And I believe that virtual labs definitely have an edge because they are able to connect the last mile learner. You talked about a very important point, that is equity and inclusivity in education. But do they also spark the same excitement that we have when we go to the real physical laboratories to perform the experiments? So Dr. Uma, I want to ask you that how do these virtual labs, they enrich our learning experience, especially when it comes to learning of abstract concepts?
Yes, definitely. Virtual lab enriches the learning, and as Priyanka ma'am already explained the benefit of virtual lab. So there are a variety of way in which the virtual lab enriches the teaching learning process in physics. See, you can see that variety of features are available in Diksha in virtual labs, like theory is there, procedure is there, animation is there, digital simulations are there, various videos for respective experiment and demonstrative activities are there. So which helps to observe and inquire the particular process and phenomena.
Yes.
As well as it the key feature, it keeps the learner engaged, like in during the whole when they are doing the whole process or whole experiment, they can step by step do that particular practical and understand the concept behind it at their own pace, which deepens their conceptual understanding and motivates them to learn. Because step by step their confidence level will build up and they perform the entire experiment, which ultimately make them more which make them clear their understanding, right. And finally, like to visualize the invisible concepts like atomic structure is there, propagation of wave is there. So there are many interactive features are there in virtual lab, like for example, in focal length of convex mirror or concave mirror. So if the object, you can change the position of the object, and simultaneously you can see how the position of the image is changing. So they interactively see the entire procedure, which deepens their understanding level. So I think that virtual lab definitely gives the better understanding of physics concepts.
Absolutely, you hit the nail there. I really like the point, the particular point that there's so many things that you cannot see through naked eyes, and they're not safe when you are exposed to them, like radiations.
Yes,
but
yes.
you can watch them in a virtual lab while performing the experiments.
Definitely.
But we all know that virtual labs and real physical laboratories, they almost go hand in hand. It means that somewhere we are integrating them
Yes,
with
yes.
a routine teaching and learning. So Dr. Uma, I would
Definitely.
like to ask you that how do these virtual labs be integrated in routine teaching and learning of physics?
Yes, definitely. Virtual labs can be integrated in a variety of way. Like if a teacher want to do in a pre-lab learning session, suppose they want to explain a particular new concept, or they want to start a new experiment, they can just demonstrate that particular activity by using a demonstrative learning approach, where that instructor gives the step-by-step instructions to the students that how to perform that particular experiment, so that the student can do that experiment alone and a more confident manner in the lab. So if we can integrate in this method, in this way also. And secondly, we can integrate with lectures also, like a virtual lab can help students to apply whatever they have learnt in the theory part. Like suppose there is a one, this I will demonstrate also. Suppose if for grade 12th there is a one topic is there, electrostatic shielding. So that topic they have already learnt in the theory, right? Now they have to explain, they have to like do that theory and in the lab session. So how they can do that lab simulation part, so this virtual lab comes handy at that time. Okay, so this is a way. And another, like it's totally depends on teacher, like how they can use the all the features of virtual lab for different like their teaching methodology. Like many interactive visuals are available in virtual labs. They can do the collaborative learning. Suppose they want to assign a project, so in a group they can assign some project to them, so that simultaneously all the students can learn at the same time. So there are different approaches are there. So one of the approach I am showing over here, that is the electrostatic shielding demonstration. So this is a demo 2 of class 12th. I will let you know how to reach over there. So this is a basic concept of electrostatic shielding, which so first of all we know about what is this thing. Okay, what is electrostatic shielding? So this is a technique basically used to protect any sensitive electrical instrument from external electrical influence. And it is done by the electroscope, which is usually a very expensive instrument. Okay, so electroscope, because it is made up of gold foil is there here. Okay, so it is not available everywhere. So student can understand the concept of this electrostatic shielding over here, right? So normally the basic principle behind it, they already know about this theory of the this electrostatic shielding. They only want to see how exactly happens. So we can integrate this in our teaching, and the basic principle is that the electric field lines inside this metallic container is 0. Okay. So let's do this activity. This is for this we have to simply go to the virtual lab. Okay, this is a Diksha virtual labs, and they are in class 12th. It is, I have already opened it. I have already opened it. Okay, so this is a demo 2 of grade 12th.
Okay,
right? Theory is there, procedure is there, student already understood the theory in their lecture classes, only now they are applying that theoretical part over here. Okay. So when we let's start this simulation.
Okay.
Okay. So whenever glass rod is rubbed with the silk cloth, okay, due to the rubbing, what happens? There is a transfer of charges is taking place. Okay, transfer of charge takes place, and this positive charge is accumulated here. Okay, so this excess charge, when we touch through this charged electroscope, what happens? See, you can see the gold leaf shows divergence, because they already understood about this concept that like charges repel each other and unlike charges attract each other. So, here the positive charge get transferred to this metallic rod and the divergence is shown. That means the transfer of charges takes place. Now, we have to shield it, okay, electrostatic shielding. This is the concept we are learning. So, for that we just take the wire, just go to the help part. I will make it full screen.
Okay.
Just so I think I have to do it again, because I have.
So basically, you can actually, if you face any kind of problem, you have prompts there.
Yes,
you have
yes.
a section of help there.
Yes, and then step by step instructions. Learner can one by one follow that instructions and complete that particular experiment and understand the concept behind it.
Right.
You can see the gold leaf shows divergence. Now we just take a.
So even if you don't know how to do it at the first place, you will get all the help on this page itself.
Yes, actually it's hanging. Simply what we have to do, we have to take this metal can and connect it with this wire so that the earthing takes place, and put this can over here. Okay. So, what happens then again when we do the similar process of this charge transfer, this gold leaf does not shows the variation. That means we have shielded this external electric influence. So, this is the demonstration which they can easily understand and with the help of a virtual lab.
Absolutely. Well, they need to do some homework as well, because you've already provided an overview and you've already done first few steps for them, and rest they can complete. Well, I never studied sciences in the higher classes, but had virtual labs been there at that time, it would have been really easy for me to understand the concepts. Probably I would have taken this as a subject in higher grades as well.
Because complicated things are already mentioned over here. Right?
Absolutely. And virtual labs have made the understanding of complex concepts so easy, because everything is done at just a click, and then you don't have to be in presence of a teacher all the time. After some initial guidance, you are good to go. And I think that is the beauty of these virtual labs. And yesterday in our session we were talking about certain things like whenever there is a lunar eclipse or solar eclipse, people are advised not to eat, and they consider it as a myth, but they don't know that they're backed by some scientific reasoning and logics as well. Similarly, I'm sure that in a daily life, we're performing so many things, we're doing so many routine tasks that are related to something or the other, which is directly proportional, I would say, to the concepts of physics. But we don't know that there is a particular reasoning and logic and scientific reason behind that. So, Dr. Priyanka, I would like you to ask about those tasks that are so monotonous and mundane in nature for us, but they are actually backed by scientific facts. So, can you perform one such experiment through virtual lab for us, which is related to some branch of science or physics?
Okay, let me ask you a question. Have you visited to a dentist? Have you ever gone?
Yes, when I was a kid.
Okay, so all of us have gone to dentists. So they use a special kind of mirror there to see our tooth.
Yes.
So what is that mirror? That is basically a concave mirror. So the main purpose of concave mirror to use here is to enlarge the tooth so they can see it clearly.
Right.
By looking into our mouth.
Yeah.
So
that is put inside the mouth, and it's very cold actually.
Yeah. And you must have also seen the spoon.
Oh yes, spoon of
course. It is curved like this. So when you see your face here, it looks upside down.
Absolutely.
So that is also a kind of the concave mirror.
Oh, never knew that. Now I'm going to look at it with the new vision, of course.
Yeah. But problem is, do you know the physics behind it?
No.
So let me dive into the word of virtual lab.
Yes.
So that will clarify your concept why all this is happening.
Okay.
So this is a class 10th experiment in virtual lab verticals of Diksha portal. So I've opened it already. So here is the theory part. You can see it. To study the reflection in the concave mirror, and you can observe the image formation for different positions of the object. So this is the concave mirror, and all the theory it is mentioned here, how images they are formed when we keep the object at different places in front of the mirror. Okay, so next tab is procedure. Here both the kinds of procedure they are mentioned for the physical laboratory as well as for the simulators. It is mentioned that you have to show the labels, you can use the help buttons, you can drag the object which is a candle here, you can select the show ray button, and you can observe, you can record your observations in the virtual tab already there. Next is the simulation, which is our main focus, simulator.
Well, that is the most interesting part here.
Yeah. Now you will see how your face looks upside down in the spoon.
Okay.
So, first of all, it's show help. You can select show rays. These rays are the light rays that are passing through the object, and they are getting reflected back through this mirror. This blue is line or curve is your concave mirror. Now you can see it very clearly how all this is happening. This candle, it is placed in front of this mirror, and this is the image, which is a very small here, you can see with your eyes here. Okay, so let me drag this. You can see image is getting changed when we change the position of object. So it is very clearly depicted here how this image is getting changed. So below this, these are instructions. Aim apparatus, you can click next to have these instructions and perform your experiment.
Okay.
There is observation table also here. So you can select, for example, at number 1 it is written between pole and the focus. So you can select the image position,
and you can record the observation simultaneously.
I am selecting it at randomly right now. When you will fill all this, you can submit it. It will show you which whatever you have feed in this is correct or not.
Oh wow.
Okay, so to see this now, if I drag the object here, this is the point, this point P is pole, and this is focus of this concave mirror. If I keep the object here, you see the image is behind the mirror and it is erect.
Yes.
Okay, but when I drag it here, now images
Turned upside down.
as you see in the spoon. But you know, this is enlarged now. Its size is bigger than the object. Our object is here and size is bigger. So this is the concept the dentists also use to see the tooth.
I'm sure, and not just the dentists. I mean, there are magicians who perform these magic shows, and they use these scientific facts and reasoning and logic. And we know, and we don't understand what exactly happening. But here now we know how to understand these abstract concepts, and there is no magic behind it, but simple science.
Science. So a layman even who don't know about physics and science, by using this virtual lab, he can very easily understand how the images they are formed in a concave mirror.
Yes. Oh, well, I myself feel like performing some experiments, and with concave and convex, I'm recollecting all that I've studied, that, you know, especially when you wear spectacles also, you have different type of lenses. I'm sure that you can also understand how images are formed and everything. But this is about optics, and thank you for reminding me of my good childhood days. Of course, as I said, now I will look at the spoon and I will myself see how things are happening, and now I will know the science behind it. And then there is another common experiment that, of course, we used to perform as kids in lower classes, and that is about magnetic properties of a magnet, bar magnet. So, Dr. Uma, I want to understand that it's not just magnet, but there are many other materials who have you know, magnetic behavior. So, why don't you demonstrate some activity that is related to that only, and through virtual lab, so that we can understand it better?
Yeah, sure. So this is a experiment like magnetic field lines around the current carrying conductor. See, normally magnetic field, there are two sources are there. One is bar magnet only, and another is a current carrying conductor. Both produces the magnetic field, right? So bar magnet normally like magnetic field is around it. Everyone, like we can see in usual experiments that thing. The another practical which is I want to show is through the current carrying conductor,
Okay.
what will the magnetic field is there and how this magnetic field behaves on changing the distance from the current carrying conductor, right. So, there is a theory is there. You can I have already opened it. This is a grade 10th. So, first of all, I will let you know how to reach over there through this thing. So, from Diksha. So, simply we have to go to the URL diksha.gov.in, and there is a different focus areas are there, and one of the focus area is virtual lab. Okay, one of the focus area is virtual lab, and through this virtual lab vertical there are from class 6 to class 12th all the practicals are there. So, this is a grade 10th experiment in English medium. I click on the English medium and science. Okay. So, now I have already opened it. This is a 53rd number. I have already opened for time constraint. Okay. Okay, I have already opened this thing. Okay, that is a 53rd experiment of class 10th, right. So, the theory behind is simply the magnetic field lines around the current carrying conductor. We have to observe the magnetic field lines and how on changing the direction of current, what happens to this magnetic field, right. So, like this is a thing which is used in motors also, right.
Okay.
And here step by step procedure is given, what are the different things are required. Simple current carrying conductor is there, okay, and this is a simulator experiment is there, you can see this. Now, see, the learner can manipulate this reading, they can see that how on increasing the current the intensity of magnetic field increases. See, I am increasing the current, the magnetic field is increases, and the direction of the magnetic field is follows the Ampere's right hand thumb rule. Like you can say this, the thumb is the direction of the current, okay, and the fingers, these fingers are showing the direction of the magnetic field. Now, if I change the distance of the object, now you can see this object is here, I can change the object size from here to here. You will see that its intensity is decreasing. You can see this value over here, the magnetic field intensity, it is 9 into 10 to the power minus 8 Tesla. Tesla is the SI unit of magnetic field. Okay. Now, as it is object is away from this source, because current carrying conductor is a source of this magnetic field. Now, as it is away from the source, you can see that the magnetic field is decreasing, right. And when you making it close, the intensity of the magnetic field is increases. Now, you can see it is 2.4 into 10 to the power minus 7 Tesla. So, it is obviously much greater than that value, right. Now, what happens if I change the direction of the current? You can see this over here. I have the student can see change the direction also. They can zoom in, they can zoom out to see the all 3D structure of it. And then if I change the direction of the current, what exactly happens? You just make a tick mark over here. As soon as I change the direction of the current, the direction of magnetic field also get inverted. You can just see this, the direction of magnetic field also changes. So, this is in the concentric circles, the magnetic field is is there for the current carrying conductor. So, this is one of the nature. The student can easily see how the magnetic field is formed around the current carrying conductor and what is the nature of it and how its intensity is increases or decreases and on what factors this magnetic field depends. Then after this, they can go through this self evaluation, like the intensity of magnetic field as we move away from the current carrying conductor will what happens, increase or decrease or remains the same, increases, decreases. So, as we have seen that as we are away from the current carrying conductor, that is source, obviously the intensity of magnetic field decreases. So, we will submit it and it is like they can evaluate also whether they have understood it correctly or not. Right. So, this is the benefit of already Priyanka ma'am explained very well. This is they can self evaluate also after learning the particular concept.
Well, quite an interesting experiment out there, and I must say that you get instant feedback because you can actually take self-evaluation and you can assess where you stand. Now, I really found that experiment related to optics quite interesting, and I think we are still left with few more minutes and we can have another experiment based on the same. So, Dr. Priyanka, will you do the honors?
Okay,
Yeah.
Let me again ask you a question. Have you seen the rainbow in the sky?
Yes.
What is the principle behind that? How does it form?
Well, I think it's like this little drops of water and sun rays pass through them. That's what I remember.
You
I'm not
remember
sure.
very good. Okay. Okay. There are raindrops that acts like a prism kind of a thing.
Okay.
And sun rays, light of the rays, they pass through the prism and they bend. But all this doesn't happen randomly at any angle. There is something to do with the angle of minimum deviation concept.
Okay.
Here. So as a layman, can't understand what the prism is, what is refraction through it.
Yes.
Okay. So let me go to the virtual lab portal.
Okay.
So this is the experiment here. You have to determine the angle of minimum deviation for a given class prism. So this is the URL which is mentioned below. You can go to the experiment. I've already opened it. So this kind of screen you will see when you open this experiment for class 12th. Okay. So you can start the experiment here. Then you can select the prism, means it will change the materials of the prism. You can select the angle of incidence. This is the light ray of the red color. It is going from air, which is a rarer medium, and entering into this triangle, which is a prism here.
Okay.
So it will go inside it. This is the angle of incidence, which is making, which it is making with this perpendicular red color ray. Okay. So now what happens when I change the angle of incidence here? You see this green line, it changes accordingly. So this red colored ray, it goes here, it bends, and this is the final emergent ray that will be come out of the prism. Now here is one point also, show protector. So when you click it, a protector comes there.
Right.
Okay? So when you change the angle here, you can drag this protector anywhere. Suppose you have to measure this angle of deviation. What is the final deviation? This was our initial ray and this is the final ray. So you can put it here and you can measure this angle with this D. Okay. You can also click here to show the quick results. It quickly shows you all the kind of result, you don't need to calculate it. So this is the angle of deviation and refractive index of the material. You can also record your readings in the virtual worksheet available here.
Absolutely. Now I understand that how the structure is formed, and now I don't have to imagine anymore that there are some droplets of water in sky up there and how sun's rays are passing. Well, now we are not left with much time, and I have to wind up the session over here, but it was indeed a great experience. I would say it was an experiential learning for me, because we talked about virtual labs and witnessing all these things, that how technology is basically benefiting the last mile learner, and we're making education accessible to all, especially the complex situations or concepts of subject like physics, which are always something very difficult and of course mundane for me, but not for many. And those who are interested, they can definitely use these virtual labs to get a strong foothold on the subject and its concepts, because it not only enhances your critical thinking, analytical skills, but also problem solving skills and experimentation part as well. Now, before I close the session, it's time for us to basically go through our website. Yes, the website where we will show you that how actually you can participate in the training session. So please have a look on our website. It's right there on your screen. So this is ciet.ncert.gov.in, and this is the home page. You have to go to the activities section, go to the workshop and training option, click on the same, and here you will find the current activity happening, which is online training on integration of virtual labs and teaching learning phase 3. You click on that and you will find a complete write-up on this training program, why we are having it. We're through with this session of ours on physics, and tomorrow we will be having our session on chemistry. Yes. So as I said that though it is specifically meant for our viewers from Northeast, but or phase 3, but this is open to all. Anybody can participate. This is the entire program schedule here, along with the topics and the name of the resource persons, and whatever sessions we are conducting, we are uploading them here as well for your later references. Now, how to participate? There are a few steps that you need to follow. Step 1 is registration. Click the link or scan this QR code. Second step is to watch all these programs or sessions very attentively that are streaming on these platforms. Step 3 is to participate in assessment activity. There is going to be a course, an online course, and you have to join the course, and you have to go through all the videos that are relevant to you. take up the final assessment, and if you score more than 70%, you will be granted a certificate. So please go through these points that are essential if you want to participate in the activity. And this is the link here for the same. And to submit your feedback, well, once you watch all the session of ours, you can always submit your feedback. The link will be announced soon, and it is very important, but you don't have to wait as such. Of course, simultaneously, we keep on sharing our email ID with you. You can write to us so that we can improve upon our content, our training sessions, and include newer content for you, the relevant and important one as well. Or you can give us a call during the session and connect directly with the experts. So that was about our training session, and now I have to thank both my experts here, Dr. Priyanka, Dr. Uma. Thank you so much for your wonderful contribution to the session. It was indeed a pleasure hosting you and learning a lot from all the concepts that you have made us understand today. And now it's time for me to make an important announcement. It is regarding an upcoming competition. So what's there on your screen? Well, this is the All India Children's Educational E-Content Competition. It is back for the year 2024-25. We invite teachers, teacher educators, students and independent educational e-content creators to submit their best e-content for the competition. For further details and the registration form, please visit the activities section of our official website, that is www.ciet.ncert.gov.in, or you can scan the QR code on the screen. The final date for submission is December 31st, 2024. And now, before I close, let's take a look at the live schedule, what all programs are coming ahead. Well, we started a day with Yog Shakti, and we just had a session on Virtual Lab as a teaching learning tool for physics under the umbrella theme of integration of virtual labs in teaching learning phase 3. In a short while from now, you can watch a session Ullas, and at 12 p.m. we will bring you a session on teaching learning interventions, where we will take you to the journey through the states of water. At 2 p.m. we will have a session in Urdu, followed by a session in Hindi at 2:30. 3 p.m. is the time for a session, of course, in Hindi language, and at 3:30 we will bring you a session in EVS. From 4 to 5 p.m. we will bring you a session on online training once again, and this time we're talking about ICT in the field of sciences. At 5 p.m. we will bring you a session called Sahyog. So with that, it's a wrap. This is me, Harpreet Kaur, taking leave of you, but you stay tuned for more educational programs. Namaskar.